All right, so let us start looking at arc, sectors, and segments. So we're going to start out by talking about by saying what a sector is. So this says a sector is a slice of a circle that is cut from the circumference down to the center. So a sector is like a slice, and everybody understands this idea of a slice. You have a slice of cake, a slice of pizza. Everybody understand the idea of a slice. Now, a sector is a slice of a circle that is cut from the circumference down to the center of the circle. Now, the straight edges of the sector are radii of the circle, and the curved edge is an arc, which is part of the circumference. So guys, this is a sector. I'm going over it in red. This is a sector. And the sector has 3 edges. It has 2 straight edges, and it has a curved edge. Now, the straight edges, because the circle is cut from the circumference down to the center, the straight edge is the radius. And the curved edge is called an arc, and an arc is just a part of the circumference. All right, so let's say that again. We said that the straight edges of the sector are radii of the circle, radii being the plural of radius, and the curved edge is an arc, which is a part of the circumference. Stay with me. So let's have a look at this shape here, guys. So a slice of the circle is called a sector. You have a minor sector. Now, the minor sector essentially is just a slice that is less than a half of the circle. If a slice is less than a half of a circle, it is called a minor sector. If the slice is more than half of the circle, that sector is called a major sector. Guys, the arc for the minor sector is called the minor arc. The arc for the major sector is called the major sector. Now, in this diagram here, it's a sector. The sector is a slice of a circle. A sector has 3 edges. It has 2 straight edges. Now, because this sector is cut from a circle, the straight edges of the sector, they are radius of the circle, and the curved edge is part of the circumference. Guys, a sector has 3 edges, 2 straight edges, and a curved edge. Now, the area of a sector is a fraction of the area of the entire circle. So the area of the sector is theta over 360 multiplied by the area of the entire circle. Theta is called the sector angle. So this angle here is called the sector angle. So the area of a sector is theta over 360 multiplied by the area of the entire circle. Stay with me. So the area of a sector is theta over 360 times pi r squared. Guys, the length of the arc is a fraction of the circumference. So the length of the arc is theta over 360 multiplied by the circumference. It is theta over 360 times 2 pi r. Lastly, the perimeter of the sector. Now, the word perimeter means distance around. To get the perimeter of a shape, you must add all of the edges, the lengths of all the edges of the shape. The sector has 3 edges. 2 of the straight edges, the 2 straight edges are radii of the larger circle. So the perimeter of the sector is L plus L, those are the 2 straight edges. Sorry, R plus R, those are the 2 straight edges, plus L, which is the length of the curve edge. Guys, example 12. Example 12, you have A, you have B. There is no, well, there is a C. So let me do A, and then I want you to do B. I'm going to do A, and I want you to do B. A says, sorry, example 12 says, for each of the following sectors, calculate the area, the length of the arc L, and the perimeter of the sector. Pi, ladies and gentlemen, is pi is 22/7. So let's start with the area. The area of the sector, the formula is theta over 360 times A, which is the area of the entire circle. So it is theta over 360 times pi r squared. So the area of the sector is theta, the sector angle is theta, and the sector angle is 36 over 360 times pi, which is 22/7 times the radius. Can anybody tell me what is the radius of sector OPQ? Anybody?
10.5 centimeters.
Very good. The radius is 10.5 times 10.5. Guys, the length of the straight edge of the sector is the circumference. The length of the straight edge of the sector is the circumference. All right, so 36 goes into this 10 times. I don't think anything else can cancel, so let's just multiply the top. That is 22 times 10.5 times 10.5, divide by 10 times 7 at the bottom. So the area is 22 times 10.5 times 10.5 divided by 10 times 7. All right, so I'm using my calculator. So 22 times 10.5 times 10.5. This is 2,425.5 divided by 10 times 7, which is 70. And the area I got is 34.65. I'm assuming it is centimeters square. So we got the area. Let's see what's the next thing we're asked to calculate. The next thing we're asked to calculate is the length of the arc L. So this length here, the length PQ. PQ is called an arc. It's the curve edge. The curve edge of your sector is called an arc. And the length of the curve edge. So L is equal to theta over 360 times the circumference times the circumference. So it is theta over 360 times 2 pi r. So L, the sector angle is 36 over 360 times 2 times 22/7 times 10.5. 36 goes into 360 10 times. 2 cancels this, leave 5. Therefore, L is equal to 22 times 10.5 divided by 5 times 7. Using my calculator. So it's 22 times 10.5 divide by 35, because 5 times 7 is 35. And L, the length of the arc L, is 6.6 centimeters. So the third thing we're asked to calculate is the perimeter. Now, the perimeter of the sector is the length of the three edges. So it's R plus L. So it's 10.5 plus 10.5 plus L, which is 6.6. The perimeter of the sector is, we have 10.5 plus 10.5 plus 6.6, and I got 27.6 centimeters. Guys, please remember, the unit of perimeter is the unit of length. So the unit of perimeter would be centimeter. The unit of area would be centimeters square. Guys, what I just did for A, I want you to do for B. You're to calculate I, the area of the sector. You're to calculate the length of the arc AB. And I, you're to calculate the perimeter of the sector. Please work out the entire question, then type all three of your answers in the chat. All right, so for B, the first thing we're asked to do is we're asked to calculate the area. So the area of a sector, the formula is theta over 360 times the area of the entire circle, which is pi r squared. So in other words, the area of a sector is a fraction of the area of the entire circle. Theta in the formula is the sector angle, which is 72 over 360 times pi, which is 22 over 7, times the radius, which is 14, times radius again, which is 14. Remember, the straight edge of the sector is the radius of the circle. 72 actually goes into 365 times, 7 into 14, 2 times. So what we have is 22 times 2 times 14 divided by 5. And so the area is all right, and what I'm getting is 123.2, and the unit is centimeters square. Remember, the unit of area is centimeters square. Next, we need to know the length of the arc L. So the length of the arc L is equal to theta over 360 times the circumference, which is 2 pi r. So in other words, the length of the arc is a fraction of the length of the entire circle. Guys, the word fraction simply means piece. So this is saying that the arc is a piece of the circumference. That's all it is saying. The sector angle is 72 out of 360 times 2 times pi, which is 22 over 7, times the radius, which is 14. Listen to this, goes 5 times. 7 goes into this, into 14, 2 times. So what we have is 22 times 22 times 2 over 5. And the answer here is 88 over 5. And the answer here is 17.6 centimeters. Lastly, we're asked for the perimeter of the sector. Perimeter simply means distance around. So it is the perimeter would be equal to R plus L. So it is 14 plus 14 plus 17.6. So it's 14 plus 14 plus 17.6. And the length of the perimeter is 45.6 centimeters. All right. Let's turn the page and have a look at C. All right, so let's read C again. In C, we're told that in the diagram below, OAB is a right angle triangle. And once I hear right angle triangle, you must be thinking things like Pythagoras theorem and trig ratios. And OAC is a sector. We're to calculate to 1 decimal place the radius of the sector. So from this diagram, I can see that both OA and OC are sectors of this, are radius of the sector. They are radius of the unshaded sector. All right, to find OA, let me ask you this. I'm going to use the right angle triangle. What is this side to the 55 degrees?
Opposite.
Opposite. What is the radius to the 55 degrees?
Adjacent.
Adjacent. Which trig ratio includes opposite and adjacent?
Tangent.
Tan. So tan is equal to opposite over adjacent. So the tangent of 55 degrees is equal to opposite 13 over adjacent R. Guys, if I have one fraction is equal to one fraction and I want to get rid of the fractions, what must I do?
Cross multiply.
Cross multiply, we get R times the tangent of 55 is equal to 1 times 13, which is 13. Then if I divide both sides by the tangent of 55, I'm going to get R is equal to, so R, this is 13. 13 divided by tan 55. And what I get to 1 decimal place is that R is 9.1 centimeters. The radius R, which is OA, to 1 decimal place is 9.1. Now let's go for the area of the sector. Area of sector is equal to theta over 360 times the area of the entire circle, which is pi r squared. So this is 55 over 360 times pi, which is 3.14 times the radius, which is 9.1 times the radius, which is 9.1 times 9.1. All right, so let's work. I'll just work this in my calculator and write the answer. So if I multiply everything at the top, I'm going to get 55 times 3.14 times 9.1 times 9.1. And then I'm going to divide this now by the only thing that is at the bottom, which is 360. And the area of for the sector that I got is 39.7, and this would be centimeters square. The area of the sector is 39.7 centimeters square. Then we're asked to determine the area of the shaded region, and everybody should be able to be aware or should be able to see that the area of the shaded region would be the area of the entire triangle minus the area of the sector. Because for this diagram, I'm going to get the shaded region when if I take the sector from the triangle, what is left is the shaded region. So if I take the area of the triangle from the area of the what? Sorry, if I take the area of the sector from the area of the triangle, what will be left is the area of the shaded region. So area of the shaded would be the area of the triangle minus the area of the sector. And the area of a triangle is what? Half base, which is 9.1, times the height, which is 13, minus the area of the sector, which is 39.7. All right, so a half is the same as saying 0.5. So it is 0.5 times 9.1 times 13. This is 59.15 minus 39.7. So minus 39.7 to one decimal place. The answer is 19.5 centimeters square. So the area of the shaded region would be 19.5 centimeters square. All right, let's see what's coming next. All right, segment is coming next. So I'm gonna stop this video.